Okay, so welcome back. So now in this video I'm going to walk through an example of how to use the logistic growth model in an example. So this is an application type of example, so I'm going to read it, so take notes, and then I'm going to write the information on the board and walk us through it, okay? So it says, an influenza epidemic spreads through a population rapidly at a rate that depends on two factors. The more people who have the flu, the more rapidly it spreads. And also the more uninfected people there are, the more rapidly it spreads. These two factors make the logistic model a good one to study the spread of communicable diseases. And clearly there is a maximum value for the number of people infected, the entire population. For example, at time t equals 0, there is one person in a community of 1,000 people who has the flu. So, in that community, at most, 1,000 people can have the flu. Researchers find that for this particular strain of the flu, the logistic growth constant is B equal to 0.6030. Estimate the number of people in this community who will have had this flu after 10 days. Predict how many people in this community will have had this flu after a long period of time has passed. Okay, so now let's write the information down. So let's start with the logistic growth model. Okay, so we have f of x equals c over 1 plus a e to the bx. Okay? Oh, sorry, it's negative because it's taken away. Okay, so there's our logistic growth model. Now, what information did they give us? Let's see here. So we start out with t equal to 1. Okay, so at t equal to 0, so a couple things. When t equals 0, the initial point, right, we know that the initial point is going to be what? It's going to be c over 1 plus a. Okay, right, so at t equals 0, what do we have? F of t, well in this case, okay, so we know at t equals 0, the reason why I'm pausing is because they have x, and I believe the x should be t. Yeah, I'm going to put t because we're talking about time, so that's why I don't want to confuse anyone. So this is t, because again we're talking about time. So x is the independent variable, and in this case it's time, so I'm just going to use t. So f of 0 then equals c over 1 plus a, but at that point there's only one person. So it's going to be 1. Now c is the carrying capacity. So we know c is equal to 1,000, right? That's the maximum number of people in the community. So we need to find a. So in this case here, it's going to be 1,000 over 1 plus a equals 1. And so I'm going to multiply both sides by 1 plus a. So I'm going to get 1,000 equals 1 plus a, which means a is going to equal 999. Okay, so there's a. Well, that's good. So now what I'm going to do is I'm going to fill my numbers in. So that means this is going to equal 1,000 over 1 plus 999 e to the negative bt. Okay. So now what other information do they give us that we can use? Well, let's see. B, oh, they give us B. B is 0.6030. Okay, so they give us B. So it's 0.6030 times T. So again, the growth constant B is 0.6030. Okay, now we want to know, estimate the number of people in the community who have had the flu after 10 days. All right, here we go. So now we want to know how many people, so we're going to solve for F, right? So let's solve for F of 10. So we're just going to plug and chug at this point. So it's going to be 1,000 divided by 1 plus 999 e to the negative 0.6030 times 10. And so at this point I could just plug this into my calculator, which I will. So now, what do you get? You get approximately 293.8. Okay, so obviously we don't want to round. We're going to round because obviously we can't have a fraction of a person. So I'm going to say 294 people. So approximately 294 people will have had the flu after 10 days. Now in the long term, now in the second part of the question is say, okay, well, how many people are going to have had the flu after a long period of time? Well, the only thing we can say is obviously after a long period of time, obviously the maximum number of people that can get the flu based on this scenario in this community is 1,000 people. So that's the answer for that one. So long term, what, a year? So yeah. So in this case, after 10 days, there'll be 294 people. If we go over a long period of time, then what we can say is that the maximum number, it'll be 1,000. Okay? Because that's what it's going to go towards. It's going to go towards the carrying capacity. Okay? Now, you can also ask questions about time. Like I could find, okay, well, how much time will have passed in order to affect half the population? In other words, that that 500 people are infected. Okay, that would be another type of problem you could ask. Okay. Well, that's it. Have a great day.